Hello students, welcome to WebStudyz. My name is Abhishek and today we will be covering Reynolds number which comes under mechanical properties of fluid. Fine. So this is a very important topic from JEE main and advanced point of view. So what is Reynolds number? Basically Reynolds number, it is defined as the ratio of inertial forces to viscous forces. It is a dimensionless quantity firstly. Fine. And it is basically used to determine flow pattern as they are laminar or turbulent. Fine. When they are flowing through any pipe or any medium. Fine. So the relation of Reynolds number, this can be given as the definition suggests, inertial force by viscous force, or we can write Re. Re is basically Reynolds number. It is equal to rho Vd upon mu. So here rho is the fluid density, V is the velocity of flow, D is the pipe diameter, and mu is the fluid viscosity. Fine. Now, why is it important? Fine. So it is important because Reynolds number, it gives us the prediction of flow pattern, whether it is laminar or it is turbulent flow. So as this diagram suggests, in laminar flow, when fluid it moves smoothly in regular path, which is known as laminar flow, and when there are irregular patterns observed and the fluid is not flowing smoothly, it is called turbulent flow, as the name suggests, turbulent. Fine. So the condition of laminar flow is that the Reynolds number, when it is less than 2000, the flow is laminar. Fine. And for turbulent flow, if it is greater than 2000, then the flow is turbulent. Fine. One more thing we have, that is in between the laminar and turbulent flow, which is known as transitional flow. So when Reynolds number, it is between 500 to 1999, the flow is basically transitioning from laminar to turbulent. So this we call as transitional flow. It is not a type of flow, but it is basically suggesting us the transition between the laminar and turbulent flow. Now let us understand what are the applications of Reynolds number and where it is applied in real life. So very first one is flow classification, so as to determine whether it is laminar, turbulent or transitional flow, that we discussed just now. Another one is heat and mass transfer. So it influences the transfer rate. Fine. The turbulent flow, they enhance mixing and also improve the efficiency in heat exchangers and reactors as well. Fine. Thirdly, it is used in aerodynamics and design. So they help to study flow around objects like airplane wings or cars, we can say, so as to reduce the drag and optimize their performance. And lastly, we can say scaling in experiments. So they ensure dynamic similarities in small scale models, also real world systems, like we can say in tunnel tests, wind tunnel tests. Fine. So now let us solve questions based on Reynolds number. So it is said that water from a pipe is coming at a rate of 100 liters per minute. If radius of the pipe is 5 centimeter, the Reynolds number for the flow is of the order. Fine. So firstly, density of water is given and coefficient of water is also given here. Fine. So we can write for Reynolds number formula Re Reynolds number, it is equal to rho V d by mu. So what are the data that we have? We have the data of rho, that is equal to 1000 kg per meter cube. Fine. Then we have the value of mu, This is 1 m Pascal second, means 1 millipascal seconds, which we can write as 10 power minus 3 Pascal seconds. In SI unit we can write. Apart from that, here we don't have the volume, we have the volume velocity. So we have volume velocity, volume velocity, let's call it as V dash. Okay, so volume velocity is basically volume into area, that is V into A, area. So volume velocity, V is our volume. So here we have the volume velocity as 100 liter per minute. So 100 is equal to, we have volume, we can say V into area of the pipe. Here area is cross sectional area. So we can refer as pi into r square. Then what is r here? So r is 25. So r is 5 basically. So we can write 25, and this 25 we can later on converting in meter, we can write 0.25. Fine. So from here our volume will be 0.21 meter per second. Fine. Now we have got all the values. Let us substitute all the values in equation 1 and calculate the Reynolds number. So Re equal to rho. Rho is here 1000 into V. V is 0.21 into density into D, that is diameter, not density. So diameter is, radius is 5, so 2 into 5 into, we have to multiply it by 10 to the power minus 2 so as to convert it into meters. Rho Vd divided by mu. Mu we have calculated, it is 10 to the power minus 3. Fine. Calculating all these, we will get 2.1 into 10 to the power 4. So from here we can conclude that therefore order of our Reynolds number it is 10 to the power 4. Fine. So now let us solve one more question to understand the concept more. So here it is given that we need to calculate Reynolds number if fluid is having viscosity 0.4 Newton second per meter square and relative density of 900 kg per meter cube through a pipe of 20 mm. Fine. And velocity is 2.5 meter. Fine. Therefore we can write viscosity of fluid is given here as 0.4 Newton second per meter square. Fine. We have been given density of the fluid, that is 900 kg per meter cube. Fine. And density of the diameter of the fluid, D, So diameter is 20 mm. So if we multiply this by 10 to the power minus 3, we will get in meter. Fine. Now we can write our Reynolds number. The formula is rho v d by mu. The velocity was 2.5 meter per second. It will be per second. Fine. So we can substitute the values. We get 900 into 2.5 into diameter, that is 20 into 10 to the power minus 3 divided by 0.4. If we multiply and solve all these, we are going to get 112.5, and there will be no units since Reynolds number is a dimensionless quantity. Fine. So I hope you understood the concept as well as the both of the questions. Thank you.